Hi, welcome to our presentation, Web-Based Tools and IDEs. I am Stefan Dieriks.
My name is Maximilian, and we would like to start with why are we even qualified to talk about that? Where do we come from? So we are a company that transformed from a desktop application company. So a couple of years ago, we did RCP applications to a web company, and I'd say almost 100% web company in that time.
And actually, we are key contributors and maintainers of open source web technologies, for example, Eclipse Theia and GLSP. Also, we are a consulting company, so we have a lot of clients, and many of them are also moving to the web, so we are helping them. Regarding web technologies, so this is a very large area. So, let's see whether the technical difficulties can be solved. Otherwise, we will just continue freestyle. So
we lost the beamer.
Let's see what's going on. Can also try some things. But if this, let's go back. I will try the mirror. Okay, we are back. So I see no color change, so that's good. Okay, so web technology is a very large area. So what are we going to talk about today is IDEs and IDE-like applications.
So what are IDE-like applications or the tools that we talk about? It can be RCP applications that you know, or Theia applications that we see on the right-hand side, so web-based applications. And what these applications have in common, they have a very technical audience. So they are geared towards people that are very technical. Typically, they use a workspace, which is a folder structure, and you have files in the folder structure. If you double-click one of the files, you get an editor, usually very technical editors, code editors, or also sometimes graphical or form-based editors. So all in all, this is to a very specific audience.
Regarding audience, we have an audience question. So who of you is actually maintaining an Eclipse-based application? Eclipse RCP-based. Okay, that's about half of you. And who of you is considering a migration to web-based technologies or already have a tool there? That's again about half. Interesting.
So we will convince the other half.
Yes. Okay. With this, we come to the first of three topics which we are going to look today. So if you start with web-based technologies, the first thing that you have to do is you have to select some of them. And when we think about web-based technologies, when I think about them, this comes into my mind. It's super fast-paced, a lot of technologies, and every day there are more and more.
However, in the recent times, this really slowed down, and many of those technologies consolidated, and there's a lot less choices, which is really good. And if you consider that in the scope that we set, there is a couple of good choices that you can make, but nevertheless, you have to make some choices.
Yes. And with this, we come to our first best practice of today, which is, whenever you have the choice, use boring software.
That doesn't sound very convincing, but what do we mean by that? So there's often the tendency, I think, in development teams and probably with yourself to just try the new hot stuff that's out there, some new framework that just has recently been released. And if you look at the scope that we set out, this is tools that are typically maintained for a decade or longer. So you really can't afford to make a non-conservative choice there. And we look at that as the example of React. So what about that?
So there are some key factors why you still want to choose React today. React is 10 years old, so it gets a little bit boring. However, there's a lot of knowledge about it out there. And there are some known downsides, but there are also recipes to work around them and make you able to use it efficiently.
And there's not only knowledge out there that you can search and find, but there's also a lot of people that have that knowledge internalized and they know how to use those frameworks.
And last but not least, there's a huge and stable ecosystem. So chances are any integration that you need is already there or can be easily accomplished. However, you cannot always use a borrowing software because you might have a special use case, right? There's a reason you built your tool, so sometimes this doesn't apply. But what do you do then? And for this, we have the best practice for you, that only after careful analysis, you use new software. For this, how do I do this careful analysis? We have a handy checklist for you.
So first and foremost, you need to think about this new piece of software, framework, technology that you want to use. Does it actually have a unique and significant selling point? So something that's so special about it that we really want to use it. Like it's more performant by 50%, or it does have features that make it so much easier to implement something that the efficiency will be so much higher. You also have to look at who is maintaining that piece of software, right? Are there regular updates? Are bug fixes being done? Can you actually contribute yourself? So is there precedence that other people were successfully contributing from outside the core developer team? And very related to that, how stable is the community? Because remember, you want to have that framework around for 10 years. So you need to make sure that there is not only one company maintaining it and that these companies have a healthy relationship. So for example, they're building strategic products or projects on top of the technology. So you can trust that it's being maintained.
And then obviously it should be compatible to your tech stack. Sure, you will check that it's technically compatible, but there's a pitfall here. You might not think about legal compatibility. So regarding this point, we want to dive into, let's say, a case study about VS Code. Let's say you want to base your web-based tool on VS Code, and you think, I know VS Code, that's open source, right? So I should be settled. But you have to check, it's only the core which is open source.
Also, when you want to just take VS Code, add a bunch of extensions and then redistribute it, like you maybe have done previously with your RCP application, this is not possible. The product is proprietary, so you cannot just take it and redistribute it.
Also, not only is the product proprietary, also some features are proprietary. So you settled on a fork of VS Code as your base, and then you want to use the collaboration feature? Not possible.
In addition, the marketplace is proprietary. So if you thought about just accessing the marketplace with your open source fork, or if you actually want to have an alternative marketplace where you curate your extensions that you want to make available to your users, not possible.
And don't only look at VS Code itself, also look at the environment. There's a sad tendency that more and more things are closed down by Microsoft. And one example are also the language servers. So about a year ago, there was a very popular Python language server, and this was deprecated and replaced by a proprietary alternative. So could happen to you that you then stand in the rain.
So all in all, summarizing, I mean, this is just one case, but it can easily happen that technically something is feasible and compatible with your tech stack. But if you dig into the licensing and legal issues, it might not be possible the way you expected it to be.
Okay. Enough of licensing, let's take a look at development and architecture. Now, you want to start development, there's something that is very dear to my heart, because there is today absolutely no excuse to not do the following things. You should have automated formatting, automated linting, continuous testing, automated releases, and whenever you do reviews, there should at least 2 persons looking at something before it goes into your code.
So all things that you invest into the development environment that will, on the long run, just give you more efficiency and just make development also more fun. What we mean by automated deployment, I just want to elaborate on that a little bit. The idea of that is if you're building a web application, it's easy to also, easy in quotes, most of the time it's easy to also deploy it automatically. So when in an ideal scenario, and we actually do that for a lot of our customer projects, and it turned out to be really a time saver, is you build your application, you build a release automatically. For example, you build a Docker container, you push that Docker container into a registry, and you launch, you configure your cluster, your Kubernetes cluster to actually use that. You launch an application on the cluster, and then you contribute or comment back the URL for accessing that application onto the PR. So what you get in essence is if someone, a reviewer, comes along, they can review the code like they can do with GitLab or GitHub, but they can also click on that URL and they're taken to the cluster, to the application in exactly the state that represents what has been done in the PR. And that's super useful for a technical reviewer, but also for something like a product manager that wants to see, okay, how is this feature coming along? Do I like the results of that feature?
And to accomplish all that, you should have a fast feedback cycle and don't shy away for custom tooling. So it takes some effort, but it will really pay back on the long run. Okay. Development is fine, but what do I develop for? I also have to think about where I'm going to deploy my software. And in all times, okay, you had an Eclipse RCP-based IDE. Okay, yeah, you deploy it to a desktop. That's it. Now you have your shiny new web tool, and now you have to think about when it runs in the cloud, which part of the functionality will I actually run on the client machine in the browser, and which part will run on the server somewhere which I can control. Also, which other cloud services do I integrate? And maybe my front end is so complex that I have to think about building it more efficiently. So some parts, for example, I run in a web worker. Now, that's not your only choice with web technologies. Maybe you want to just deliver a static application without any special needs on the back end. So you might settle on this deployment.
And then, of course, which is just from practical experience, a very common case, people still want to have their desktop application, at least to begin with, because that's where they come from. So what you can do with the stacks that are out there, oftentimes you basically single source a desktop and a web application or a cloud-based application. And the advice that we have there is, if you want to do that, if that's where you want to go to, even if you don't use, for example, the cloud application right now in production, but you want to be able to have it in the future, build both from the very beginning and test both from the very beginning. Because there are subtle differences, right? I mean, to just name one that's obvious, there's latency between the backend and the front end in the cloud deployment. And if you don't build and test that, you will have a desktop application that works just fine, but maybe has issues if it runs as a cloud application.
So with that, we talked about the development environment, we talked about deployment. Now let's talk about architecture. And this time we want to first look at a detailed example and then work up to our principle. So let's say you are building your React-based UI. So this is your React component tree and everything is fine. Now what you want to do is you want to render some dynamic data, for example, a list of users. So you just into this one component, you add the fetch somewhere from the data, and once you get it, you render, and that's it. Now, this looks fine, it works on a first glance. However, there's a pitfall here, which is that this code is no longer portable. What happened here is that a component is reliable for rendering and fetching data. And when you just want to render this, for example, on a server side where you have limits to access other cloud services, or even in some sandbox, you can't just access the web. So this React application will not just work out of the box. Instead, a better approach is that you need to separate your concerns. And in this concrete example, this could look like this, that instead of just adding the fetch somewhere in your components where you need them, you extract it out into a separate object, for example, some kind of API accessor. And there you can just do the same thing again. So here you can talk to your cloud services, or then if you are in a different environment, you can just reuse your whole component tree and just exchange that one API accessor and develop something else, for example, communication via messages.
So on that level, that's something that might be very clear, that you separate the concerns there, but actually this strategy is also very useful on an architectural level. And I would like to look at an example how we applied that on an architectural level. And the example is GLSP. So if you're not familiar with GLSP, it's about building graphical editors with the same principles as language server protocol. So the idea is that you have a front end, and the front end doesn't really understand the semantics of the underlying model. It only knows how to render the graphics, so the graph, and how to provide you with a palette, and it lets the user interact with the diagram. But then you have a backend, and the backend really understands the semantics of the graph. So it knows, for example, which nodes can be connected to which other nodes, and it's also responsible for taking in a domain model that you have and figuring out which parts are displayed as a graphical model. And the two are connected via messages. And you can see a clear separation of concerns there. The front end is only concerned with displaying what I would almost call a presentation model, while the back end is really concerned with figuring out how to come up or how to project a presentation model from a domain model. Also, at some point, this domain model must be loaded and stored. That's, again, separated out into a separate component so that it's not the responsibility of the backend directly. And with that setup, we would like to just iterate through the different deployment scenarios that we had previously to show that this architecture and the separation of concerns pattern in this architecture now applies to all the scenarios in the desktop and in the cloud-based way.
So let's just take a look at some of the integrations that we did. They are not even all of them. So for example, we integrated GDSP into Theia. So Theia is a framework for building web-based IDEs. And the interesting part is it itself consists out of a front end and a back end. And here the integration was just supernatural. So on the back end, we can easily instrument the GDSP server. And in the front end, because the front end itself also is developed in a way which is very standalone, it could be easily integrated into a Theia widget. Not only that, because the GDSP server is easily run everywhere, it can not only run as a separate application, but we were also able to run it in process if this is something which you like, for example, for easier deployment. Then we also integrated GDSP into VS Code. So VS Code can be enriched by VS Code extensions. And all what you had to do is render the diagram editor in a web view. So it was integrated in the UI. And as part of the extension host of the VS Code, we were able to run the GDSP server. Then there's the static web application use case, where we were also able to run GDSP. So this is the browser on the client's machine. And as always, we can just easily render the diagram. And then the GDSP server was just part of a web worker. So as you can see, following this architecture strategy, you are able to very flexible fit it into your use cases.
So this is all the good new world that you could go to. But as we've also seen in asking you about it, you all have these legacy applications. Maybe you don't consider them legacy yet, but on the long run, from my perspective, you eventually have to think about where to migrate to, and it's just a question of time. And then we come to this valley of tears of migration, because that's not an easy topic. So obviously there is different approaches to doing that, and I would even say there is a full range of different approaches. And on the one hand side, you could just go down the strategy to say, I want to reuse as much as possible. Then you could go to the extreme other end and say, well, I'll just throw away everything and I'll do greenfield. And there's some middle ground where we will propose one proposal that we call iterative. And we will now look at these different proposals in the following.
Okay, so let's just take a look at reuse. Now, this is a very tempting approach at first, because in your existing RCP-based application, you often spend decades worth of person days in there just to get your polished state which you are currently having. So it's obvious how can I reuse the most of it for my web-based technology. And the idea is that it looks like this. So your new users will then just see this shiny new web front end, and they will not even know or care about that the main functionality is built on your old application.
So this is a pitfall for two reasons. First reason is, in our experience in the projects, and actually I've been in that pitfall many times. You overestimate the value of the reuse, because the application that you have is maybe very old. The user base might have shifted, so you have features that are not even in use anymore, or to stay in the picture, you have some rooms that are not inhabited by anyone anymore in the building. And usually something is also true about applications. 80% of the use cases, 20% of the use cases make up for 80% of the usage. So you have a part of your application, a large part of your application that doesn't see that much usage. And maybe that's also something where the reuse is overvalued. And then on the other hand, which is the opposing factor, if you build the building like that, it looks like that might just be fine, but we said that basically you combine two technology stacks, and there's friction, and it's a little bit intangible. Where does this friction come from, right? It doesn't feel like something that is. It's not one thing that's wrong with it. It's basically, I think, two things that create that friction. One is you have to have a development team that can deal with both stacks. That's just much more difficult to find people or to educate people to be able to do both. And the other friction is really technical friction. Just one example, if you have two technology stacks, you eventually hand off data from one to the other stack. And chances are the data format is not the same. And if the data format is not the same, you have to convert, and probably you even have to convert back and forth, and you don't want to lose any data. So there is really some problems in that. So I would really only recommend to do that after a careful trade-off analysis. I mean, truism again, yeah. But this one is really, really dangerous, and I think we really learned in the past from how to do this trade-off, because there's something you also have to keep in mind. The value of reuse is a one-time value. You only have you get it once, but this destructive resulting friction is something you carry around with your project that maybe lasts another decade all the time. So if you do that trade-off, keep in mind the friction, you basically have to multiply that by 10, and the value that you get is only one time.
Okay, all of this sounds very exhausting. Can't I choose a different approach? Yeah, I go greenfield. Okay, this is nice. I can just construct my tool as I want, and finally I can do it right. But obviously there are also pitfalls there. And just what I said here, if you don't learn from your old tool and you realize, yes, I get the new tool, it's very easy that you repeat the same mistakes. So for example, you had some UI integration with your functionality which you shouldn't have. This can also be done in web technologies, so it's not automatically better. Also, if your team is not well versed with web technologies yet, it's easy that you stumble into new mistakes. So you need to make sure that you are properly educated. Then it's easy to underestimate the effort which it takes. That's clear, but it's just something which happens time and time again. Just think about how much effort you spend on your old application, and for your new application, realistically, you will have to spend the same effort again. Also, this will take time. And because you underestimated the effort, you maybe also underestimated the time span. So you have to think about, what do I do with my legacy application? Because when you just announce your new 2.0 application, and now it takes 3 years, and all users are disgruntled, nothing happens. So that's a pitfall you can easily fall into.
And the advice we would give here is, don't fall into the trap to just start with the greenfield and do the easy stuff first. Because then you can quickly escalate into a situation where it seems you have 80% of the work done, but actually the remaining 20% of the work to be done is 80% of the overall effort. So if you go down the greenfield route for good reasons, then you need to tackle the difficult problems first. So you need to come up with a plan where maybe you start with a POC, and then you have a plan to see what are the difficult parts, and you do them first, because then you avoid this trap.
Okay, so we had reuse, we had greenfield. Isn't there something in between?
Yeah, and here is the silver bullet. Not, of course. So this is something in between that we have applied on some projects, and that turned out at least better than the other two options. I mean, it's never fun, this migration part. And what we propose is a 2-phase migration process. You make up a plan when you actually want to start with the next-gen app. And in the first step, in the first phase, you still only work on the legacy application, but you make different choices there. So you refactor the legacy application, for example, to create headless parts, headless services for stuff, so that it can be reused in the next-gen application. And whenever you develop a new feature, you do your very best to try to develop it with the target tech stack and just retrofit it into the legacy app. So in RCP, you can do that by running a web browser widget and then have a web application part within your RCP application. And then only in the second phase, when you start with the next-gen application, you continue that pattern to try to single source as much as possible between the legacy and the next-gen application.
Okay, but you need to be careful, and Maximilian said the keyword, you are coming close to the reuse use case. So just refer to the slides back and make sure that you don't fall into that pitfalls.
So my experience at least is you can probably, depending on your application, only do this iteration to a certain extent. To stay in the picture of the building, at some part you will get to the structural core of the building and it will become quite difficult to iterate. So I think you cannot fully avoid this problem that we mentioned earlier, but you can at least delay it and shorten the period where you have those two applications maintained at the same time.
Okay. So we talked about tech stacks, we talked about development. What is our takeaway for you today? And the key message is start planning now. So if you have any interest to going into web technologies route, it can't hurt to start as early as possible. Think about your resources which you have and think about a realistic timeline where you want to offer which part of your application as a desktop tool or in the cloud or whatever you can think of. And then based on that, think about your architecture, your deployment scenarios, and then which technologies you want to base your tool on.
Yeah. But how do you do that, right? That's kind words. Start now, do something. And I think the only way to really be able to do that is to build a proof of concept. So if you build a proof of concept, it allows you to evaluate which parts are difficult, to come up with estimates for the different parts of your application. That gives you an idea of the required resources to build that application. That allows you to put that onto a timeline based on the investments you're willing to make. It also gives you the architecture, right? In the POC, you choose an architecture, you choose technology. So it gives you what you need for the strategy that we introduced earlier to know where do I migrate to. Because only when you know where you migrate to, you can prepare for that. So in my experience, building a POC early on is really key to avoid more sunk cost. Because everything you do on the legacy application without knowing the target architecture and technology is very likely to be sunk cost, even if you plan to migrate at a later point in time. And let me just reiterate, from my perspective, it is inevitable to migrate. It's only a question of when and how well prepared you actually go into that endeavor. And with that, we would like to close.
Yeah, thank you for joining our talk. This is a QR code. You come to the presentation, so don't forget to vote. And here are some pointers to some other presentations you might want to look at.
If you're interested in AI, there's 2 presentations tomorrow and the day after tomorrow about integrating AI in the same kind of tools. Also, we have a BOF session tomorrow in the evening. And we, of course, have a booth. So if you have any questions, you can come by the booth. And talking about questions, we also have 5 minutes left for questions. So are there any questions?
Hello. Why do you think web technologies gained so much attention to develop desktop